Good morning to another present here. I'm going to explain about the topic on theodolite surveying. First, the introduction part. So far, we are measuring horizontal angles by using a compass with respect to meridian, which is less accurate, and also it is not possible to measure vertical angle with the compass. So, when the objects are at considerable distance or suited at a considerable elevation or a depression, it becomes necessary to measure the horizontal and vertical angles more precisely, so that these measures are taken from the instrument called theodolite. Then comes the theodolite surveying. The system of surveying in which the angles are measured with the help of theodolite is called the theodolite surveying. Next, we will see about the classification of theodolite. First one is based on the horizontal axis. One is transit, and other one is non-transit theodolite. And based on angle, it is vernier, micrometer, and electronic digital theodolite. First, the classification of theodolite. First, we're going to see about the transit theodolite. Theodolite is said to be a transit when telescopes are transited through, that is revolved through a complete revolution about its horizontal axis in the vertical plane, where in the non-type, the telescope cannot be transist. They are inferior in utility and have become absolute. And next to the classifications of theodolite, that is the next version of the transit theodolite. One is vernier theodolite for reading of graduated circles if verniers are used, and theodolite is called a vernier theodolite. Whereas if micrometer is provided, the graduated circle is same is called the micrometer theodolite, which gives the directly a digital number. If electronic distance measurement is attached to it, it's called a total station. And the common sizes are 8 to 12 centimeter, while 14 to 25 centimeter instruments are used for triangulation work. Greater the accuracy with the larger theodolite, as they have a bigger graduated circle with larger divisions, and hence it is used where the survey works requires high degree of accuracy. Then the uses of theodolite used to measure horizontal and vertical angles and prolong survey lines, finding difference between the lanes, levels, setting out of grades, tachymetric survey. In transit theodolite, we have the instruments, which is Vernier A and Vernier B. We have outer spindle and inner spindle as well, so that the lower clamp and the upper clamp should be fixed. To rotation, the upper clamp is fixed and lower clamp is used to calculate the horizontal and vertical angle. Next comes the these are the essential instruments that are essential equipment that are used in a transit theodolite, which is essentially used as a used for theodolite surveying for horizontal as well as vertical angle. First one is the vertical leveling head. In the leveling head, we have a in the leveling head. Next comes the T frame. The T frame it supports the leveling head and lower circular plate, which is graduated from 0 to 360 degree. We have a plumb bob to measure the center distance. We have the upper plate, which is 0 to 20 degrees, and we have a tripod stand to withstand the height of a instrument, that is for leveling, and we have a telescope to view the object view. We have two types of view in that. One is eyepiece view and another one is observing angle view. In eyepiece, we have to focus the angle, focus the image correctly so that it can be used. And we have a vernier scale, and this is the graduated scale. It is which is given. Next comes the centering, which is these are the terms used in the transit vernier theodolite. It means setting out of theodolite exactly over an instrument axis so that the centering becomes vertical, which lies immediately to the registration mark. The Shamta shifting arrangement is provided in the instrument. It helps in easy and rapid performance of centering. Then comes the next manipulating, that is, we're going to fix it. Next will be a transiting, that is, it is a plunging reversing. It is a process of turning the telescope about the horizontal axis through 180 degree in the vertical plane, so that the telescope which is rotates through it and it gives the exactly opposite direction. Next is swinging the telescope. We have two methods. We have two types that are used to swing the theodolite. One will be the horizontal axis in the horizontal plane, and another one will be vertical axis in the horizontal plane. It means we are going to turn the telescope towards face left and face right. By swinging it to the face left and face right, we are going to rotate in a clockwise or anti-clockwise direction. Next one was face left. We already seen about face left and face right in the previous this slide. By observing the horizontal vertical angle in the left side, the observation is known as the left is known as the face left observation. If we are doing it in the right side, it's the face right. And we have a changing phase, which is that the telescope is done to an angle of 180 degree in the vertical plane and then rotate through the center in 180 degree. So the first answer is choose to swing the third light at 180 degree line of collimation. It is also known as the line of sight. It has an imaginary line joining the intersection of the crosshair of the diaphragm of the object and its continued. And we have the axis of telescope, which is the imaginary line drawn with the center optical center with optical glass to the eyepiece. Then comes the axis level tube, which is also called the bubble line. It is straight to the tangential and longitudinal curve of the level tube. At the center of the tube, it is horizontal when the bubble is at the center. Next comes the vertical axis. This is the axis about the telescope can be rotated to the horizontal plane. And in the horizontal axis is also called a true union axis, where the telescope is rotated in an vertical angle. These are the readings to be taken. How the readings to be taken on the vernier scale. First scale will be the index, and second part will be the part of circle that is marked degrees from 0 to 20 degrees. And we have a upper scale and we have another vernier scale. We have two types of vernier scale. One is the angles that are given in the bottom of the scale, and in the top of the scale it is used for giving the values of degrees and seconds. And this is the fundamental axis. We have up to 6 to 7 types of we have 4 types of vertical axis, that is vertical, horizontal, and horizontal circle and horizontal axis. We have a vertical angle as well. And next comes the temporary adjustment. In temporary adjustment, we are setting up, and first we are setting up and we are centering. Next, we are leveling it, and elimination of parallax is being done. These are 3 methods that are generally used in horizontal angles. First one is general method, another one is repetition, another one is reiteration method. In the repetition method, first you have to set the station at O point, and we're going to focus. We have to we fix the vernier A to 0 to 360 degree, which is the B is automatically moved to 360 degree when we focus on the face left side, and we have to loosen the lower clamp so that we can view the object piece, we can view the object, and then we have to bisect the value of A, and then we have to move to the point B. This is the uh, horizontal angle. By you measuring the horizontal angle, we are giving the face left or face right, and we are calculating the face left and face right, which is quite common. Then comes the repetition method, which is very accurate work, because we are doing continuous. We are taking 2 angles continuously over a period of time, so that it becomes quite accurate. So that the number of repetition, when the number of repetitions are increased, the result will be equal.